dear students, let us continue the topic of numerical methods. In the last lecture, we have studied the method of false position or false position method, which is also called as regular falsy method. We have also solved one numerical based on that. That example was an algebraic equation. Now, in this lecture, I am going to solve the transcendental equation. Let us solve this numerically, of course, not analytically. The equation given is x into log of x to the base 10 minus 1.2 equal to 0. Now here we would be using the method of false position, regular falsy method. So at the outset, what do? We track the root of this equation in certain interval. How do we determine that interval? We choose 2 points, say A and B, such that f of A is, or f of A and f of B has opposite signs. If f of A is negative, then f of B must be positive. If f of A is positive, then f of B must be negative. So that we can say that the interval lies between the open interval A and B. After tracking that interval A and B, we find the consequent values of x1, x2, x3 and so on up to xn. At least 4 values. That values x1 is determined by A into f of B minus B into f of A upon f of B minus f of A. This formula is called as regular falsy formula. This gives me the value of x1. After finding out x1, find out f value of x1. Now, if this value of f of x1 is negative, and for the interval say A and B, if f of A and f of B we have chosen in the very first. If this is negative, if f of A is positive, then we choose this interval A comma x1. Because this is negative, this is positive. So this fx1 value replaces this value. Now we shall see this in example. Now here f of x1 is negative, f of A is positive. What does it mean? Root lies between A comma x1. Now we consider this as A and this as B. Again find out this x2 now. We repeat this procedure 3-4 times, and x4, x5, they are supposed to be the, if they are floating points repeated, that floating point, similar floating point, we call it as a required approximate root of the given equation. Now, let us solve the given equation. Now, given equation is, let f of x be equal to x into log of x to the base 10 minus 1.2. This is the given equation. Now we shall track the interval in which the root of this given equation exists. इसका ट्रैकिंग इंटरवल कैसे निकालेंगे? If we put x equal to 1, we know that log of 1 की वैल्यू 0 होती है. So x for x equal to 1, What is f of 1? F of 1 is equal to 1 into log of 1, 0 minus 1.2. F of 1 की वैल्यू नेगेटिव है. Now find out the f of 2. F of 2 is equal to 2 into log of 2 to the base 10 minus 1.2. That value is equal to f of 2 is minus 0.5979. This is also negative. Now for x equal to 3, what is f of 3? It would be of course equal to 3 into log 3 to the base 10 minus 1.2. So f of 3 is 0.2313. So this value is negative, this value is positive. इसका मतलब क्या होता है? F of 2 is negative and f of 3 is positive. That does mean that the root of this logarithmic equation, the root of this transcendental equation lies between 2 and 3. Hence, since we have seen that if a is equal to 2, b is equal to 3, f of 2 is minus 0.5979, f of 3 is 0.2313, f of a into f of b is less than 0, because f of a is negative, f of a is positive. So they are of opposite signs. Therefore, root lies in 2 and 3. So this is my value of a and this is my value of b. After determining this interval, x1 is equal to regular Cauchy formula for x1, a into f of b minus b into f of a divided by f of b minus f of a. That is equal to a means 2, a into f of b is 0.2313. This is f of b, this is f of a, minus b into 3 into f of a. F of a is minus 0.5979 divided by f of b minus f of a, 0.2313 minus 0.5979. So this is Cauchy one. This comes out as 2.721014. 2.721014. I'm considering the values up to the 6th decimal places. Okay. So this is my value of x1. Now f of x1, f of 2.721014. Since f of x1, that is f of 2.721014. What does it mean? 2.721014 into log of 2.721014 to the base 10 minus 1 by 2. That value comes out as minus 0.01704. It is negative. So f of x1 is negative and f of 3 is positive. Since f of 3 is positive, therefore root lies in x1 comma 3. in this interval. Now I will treat this x1 as A and 3 as B and use again this formula and calculate x2. x2 is A into f of B minus B into f of A upon f of B minus f of A. A means x1. x1 we have seen it is equal to 2.721014. 2.721014. This is A into f of B. f of B is f of 3. f of 3 is 0.2313 minus B 3 into f of A. f of x1 is minus 0.01704 divided by f of B 0.2313 minus 0.01704. This gives me the value of x2. x2 come out as 1.784200. 1.784200. This is shear calci work. So now after determining x2, I would find out its f value. Since f of x2, that is f of 1.784200 is, what is it? Is again negative. What does it mean? Now f value of this point x2 is negative and f of 3 is positive. What does it mean? It again means that the root lies in 1.784200.
Oh shit, Papa.
So friends, after determining this point x2, which is 1.784200, we check its f value sign of f value. Here it is found to be negative. That does mean that the root lies between 1.78420, root lies in the interval 1.784200 and 3. We repeat again same procedure. We consider this as A, we consider this as B. We use this formula A into f of B minus B into f of A upon f of B minus f of A and determine the next value, which is x3. So x3 comes out as x3 come out here. x2 is not this value, perhaps it is, let me, x2 is equal to 2.74211. x2 is 2.740211 and f value of 2.740211, that values we put in this f of x equation is equal to minus 0.0003895, which is again negative. This f value of this point x2 is negative, f of 3 is positive, therefore root lies in the interval 2.74 0, 2, 1, 1 and 3. We are continuously contracting, compressing the interval in which our root lies. Earlier it was lying between 2 and 3. Then it was lying in x1 comma 3. x1 means 2.721014 and 3. Now it is lying between 2.74211 comma 3. Similarly, if we repeat this process, we consider this point as A, this point as B, and again use this formula A into f of B, B into f of A upon f of B minus f of A. The value of x3 comes out as 2.740627. 2.740627, and its f value f of x3 comes out minus 0.000. It is approximately equal to 0. It is nearest to 0. 11998. So, from last two iterations, x2 and x3 values, 2.740, these three floating points, 740, they are repeating twice. Therefore, x equal to 2.740 is the approximate root of the given this logarithmic or say a transcendental equation. So, now let us switch on to the Newton-Raphson method. Let f of x equal to 0 be the equation given. We are given this f of x equal to 0 at our disposal, whose numerical solution is to be obtained. It may be algebraic equation, it may be a transcendental equation. Step 1. At the outset, in the beginning, we determine interval in which root lies. We track the root and the interval in which that root lies by selecting 2 points such that their signs are opposite, A and B. The f of A and f of B must have opposite signs. One should be positive, another must be negative. Step 2. We choose point nearer to root as x0. If the root lies between this interval A and B. So, we choose point if this is the case nearer to the root, not nearer to root, perhaps nearer to origin. If this is the interval of differencing and these are the axes, something like this, here we see that the point A is nearer to origin. So we take this point A as x1. On the contrary, if this is the case, if the axes they are something like this, for this interval we see that B is nearer to origin. So we choose x0 or x0 equal to B here. We shall see this. Okay. So x0 is to be selected like this by using this rule. Step 3. Step 3 is find x1, x2, x3 by xn plus 1 by this formula. Xn plus 1 is equal to xn minus f of xn upon f prime of xn. N equal to 0, 1, 2, 3 and so on up to. In this equation, if I put n equal to 0, it gives me the value of x1. If I put x equal to 1, it gives me x2. If I put x equal to 2, x3 chi value may and so on. So x4, x3, they are approximate roots of this given equation f of x equal to 0. That is how, this is the Newton-Raphson formula. Note this formula. And now, subject to this, we shall solve one example based on this. Solve. Example number 2. F of x equal to 2x cube minus 3x minus 6 numerically. We want to find out numerical solution by NRM. NRM is Newton-Raphson method. Solution. Given. What is given? F of x is equal to 2x cube minus 3x minus 6. In the Newton-Raphson formula, xn plus 1 equal to xn minus f of xn upon f prime of xn. There is a derivative term. So we shall differentiate this f of x. F prime of x is, what is derivative of this? It is 6x square minus 3. Now, we shall track the interval in which the root of this algebraic equation lies. So, what is f of 0? 0 minus 6. Minus 6 is a negative number. What is f of 1? F of 1 is 2 minus 3 minus 6. Minus 3 minus 6 minus 9. 2 minus 9 is minus 7. It is again negative. Now what is f of 2? 2 into 2 cube 16 minus 6 minus 6. 16 minus 12 is 4. Is positive. So for 0, it is minus 6. For 1, it is minus 7. And for 0.2, it is plus 4. So for this is negative, for this is positive. That means root lies between 1 and 2. Here. Root lies in 1 and now, what is f of 1? Root lies between 1 and 2. What is f value of 1? F value of 1 is minus 7. It is somewhere here, minus 7. Now, what is f of 2? F of 2 is 4. F of minus 7 is somewhere here. F of 2 is 4. Now, which value is nearer to origin? This 4 value is nearer to origin. 4 value is f of 2. So, see here, we choose x0 is equal to 2. Out of this pair of endpoints 2, 1 and 2, the f value which is nearer to origin, that is to be chosen. This f of 2 is 4, which is nearer to origin as compared to f of 1 value. So we choose x naught equal to 2. Now, x naught equal to 2. Now, what is Newton-Raphson formula? Newton-Raphson formula xn plus 1 is equal to xn minus f of xn upon f prime of xn. Let us substitute this value. What is xn? Xn minus. What is f of xn? This is f of x given algebraic equation. So f of xn is 2xn cube minus 3xn minus 6 divided by. What is f prime of xn? This is f prime of x. So f prime of xn is 6xn square minus 3. So xn plus 1 comes out as 6xn cube minus 3xn minus 2xn cube plus 3xn plus 6 upon 6xn square minus 3. So, I have just combined this, subtracted these two quantities. Cross multiply this and subtracted this numerator of the second term. Now, 6xn cube, 6xn cube minus 3xn plus 3xn goes minus 2xn. No. 6xn cube minus 2xn cube is 4xn cube. 6 minus 2xn cube is 4xn cube minus 3xn plus 3xn cancels out plus 6.
upon 6xn square minus 3.
So this formula, after simplification, gives me the values of x1, x2, x3 and x4.
N equal to 0, 1, 2, 3 and so on. Xn plus 1 is equal to 4 xn cube, it should be cube, plus 6 upon 6xn square minus 3.
We are almost done. Just we need to perform the calculator work.
Now, therefore, x1 is equal to, if I put n equal to 0, x1 is equal to 4x naught cube plus 6 upon 6x naught square minus 3. Putting x naught equal to 2, 4 into 2 cube plus 6 upon 6 into 2 square minus 3. So it is 38 upon 24 minus 3, it is 21. So it comes out as x1 is equal to 1.809525.
So this is the value of x1. Now find out the value of x2.
x2 is equal to 4x1 cube plus 6 upon 6 x1 square minus 3. Now in this formula, put x1 as this value, 1.809525. So it is 4 times 1.809525 cube plus 6 upon 6 times 1.809525 square minus 3. So this comes out as 1.784200. 1.784200.
This is the value of x2.
From x2 I will determine the value of x3. x3 is 4 times x2 cube plus 6 upon 6 times x2 square minus. Now in this I will put the numerical value of x2 as 1.784200, which is comes out as 1.783769. 1.783769. This is the value of x3. Again, this x3 gives me the value of x4 by this formula, 4 times now x3 cube plus 6 upon 6 x3 square minus 3. In this, if I put the numerical value of this x3 as 1.783769, I will get the value of x4 as 1.7837, same value, 1.7837.
The solution of this method converges fast as compared to the regular falsy method. This requires the lesser number of iterations. It approaches to root very immediately. Its rate of convergence is 2. So this is a very fast method.
The solution is x4 value. Hence the solution is x is equal to the last value, which is x4 value, is 1.783769.
If I put x4 equal to this in this cubic equation, 2x cube minus 3x minus 6, it will be as nearest to 0. That is how we solve the numericals based on the Newton-Raphson method, which involves the single formula. Xn plus 1 equal to Xn minus f of xn upon f prime of xn. So today we have solved one algebraic equation in this lecture. In the next lecture, we shall solve the transcendental equation by the same method, which is Newton-Raphson method. That will finish our first two methods of solving numerically the algebraic equations and transcendental equations. Thank you very, very much. Thank you, guys.